Why you're breathing dinosaur air. ASMR atmosphere. Close your eyes, and breathe deeply. That air flowing into your lungs at this very moment. It carries secrets older than the pyramids, older than the last ice age. Some of those very molecules once surged through the flaring nostrils of a towering T-Rex as it roared across primordial landscapes. They floated through steamy Jurassic jungles, swirled in the thunderous breath of volcanic eruptions that shaped continents, and lingered in the exhales of the very first flowers to ever bloom. Tonight, we embark on a journey not through space, but through time, following the ancient voyage of these invisible travelers from prehistoric skies to your bedside, from dinosaur lungs to your own. Every breath you take is an act of time travel. With each inhalation, you draw in fragments of Earth's deepest history, oxygen atoms forged in the hearts of ancient stars, nitrogen molecules that witnessed the rise and fall of mountain ranges, water vapor that once condensed on the leathery wings of pterodactyls soaring over vast inland seas. The air around you is not empty space, it's an ever-changing mosaic of planetary memory, a living archive written in atomic ink. That slight evening breeze rustling your curtains. It carries whispers from epochs when giant reptiles ruled the land, when the continents wore different shapes, when the very air thrummed with unfamiliar rhythms. Scientists call this astonishing process atomic recycling, the endless dance of elements between rock and sky, between living and non-living, between past and present. The carbon dioxide you just exhaled might soon become part of a maple leaf structure. The oxygen you're about to inhale could have last been breathed by a Renaissance artist or a Bronze Age shepherd. But most mind-bending of all, statistically speaking, your lungs almost certainly contain atoms that once resided inside dinosaurs. Not just near dinosaurs, inside them, cycling through their system. Fueling their three-chambered hearts, escaping through their thunderous exhalations some 150 million years ago. The mathematics behind this revelation is as beautiful as it is undeniable. Earth's atmosphere contains about 10 to the power of 44 air molecules, a number so vast it exceeds all the grains of sand on every beach. The average breath draws in about 10 to the power of 22 molecules. Given that all dinosaurs combined breathed an estimated 10 to the power of 33 molecules during their 165 million year reign, probability dictates that every breath you take contains at least a few molecules of authentic dinosaur air. That gentle rise and fall of your chest as you listen. You're breathing the same air that once filled the lungs of Triceratops herds thundering across floodplains, of velociraptors panting after prey, of massive sauropods whose size could ripple nearby ponds. But how can we be so certain? The evidence lies in the unbreakable laws of chemistry and physics. Atoms are indestructible under normal Earth conditions, they rearrange but never disappear. The oxygen that fueled cellular respiration in a Stegosaurus's muscles wasn't destroyed when that creature died, it returned to the atmosphere, was absorbed by plants, cycled through countless organisms over millennia, and now sustains your own cells. The nitrogen molecules bouncing around your room right now have existed virtually unchanged since Earth's atmosphere formed. They've been part of hurricanes that drowned dinosaurs, part of the wind that cooled the brows of early humans, part of 10,000 generations of summer breezes. As you settle deeper into your pillow tonight, try to feel this profound connection. With each slow, sleepy breath, you're participating in the planet's grandest ritual, the endless exchange of atoms between all living things. Your lungs have become the latest chapter in a story written in carbon and hydrogen, a narrative that began when the first single-celled organisms learned to harness sunlight. The air you're breathing now will someday nourish forests you'll never see, oceans that haven't formed, creatures not yet evolved. You are, quite literally, breathing the future as well as the past. So let your breathing slow, let your mind drift, and imagine those ancient atoms flowing through you, invisible, silent, but humming with history. The same oxygen that once ignited the metabolism of a charging Allosaurus now sparks your thoughts as you listen. The same water vapor that once beaded on giant dragonfly wings now moistens your airways. You are not separate from Earth's story, but an active participant, a temporary custodian of atoms that have seen civilizations rise and fall, species emerge and vanish, landscapes transform beyond recognition. Tonight, as sleep draws near, picture those dinosaur atoms finding temporary refuge in your body. Imagine them whispering their stories to your cells, tales of swampy Cretaceous mornings, of asteroid-lit nights, of an ancient world reborn through chemistry's endless alchemy. And when you wake tomorrow, remember, your first deep morning breath will draw in still more of these cosmic travelers, continuing a cycle as old as life itself, a cycle that connects your most ordinary moments to the most extraordinary chapters of Earth's history. The night air around you is alive with memory. Every molecule a time capsule. Every breath a bridge across millennia. So breathe deeply, and let the past gently carry you into dreams. Chapter 1, Earth's Eternal Breath. Imagine Earth's atmosphere as the greatest recycling system ever devised, a vast, invisible library where every molecule is a book that never disappears, only gets checked out by different borrowers across time. The air you're breathing right now is part of an endless loop that has been running continuously for billions of years, where atoms dance between sky and soil, between oceans and organisms, in an elegant choreography that makes all life possible. This is the story of our planet's eternal breath. How the same molecules that sustained dinosaurs now sustain you, how the water in your morning coffee once quenched the thirst of prehistoric monsters, and how every living thing on Earth is connected through this atomic exchange that transcends time itself. Let's follow the journey of a single oxygen molecule to understand this miraculous cycle. Our story begins with this O2 molecule floating high in the atmosphere, buffeted by winds that have carried it across continents. It was likely born from the photosynthesis of an ancient fern or conifer tree during the Mesozoic era, when dinosaurs dominated the land. That plant absorbed sunlight, took in carbon dioxide, and through the magic of chlorophyll, transformed them into sugar and oxygen, our molecule being one of those released as a byproduct. For millions of years, it circulated through the atmosphere, sometimes being breathed in by creatures great and small, other times dissolving in ocean waters before being released back to the air. Then one fateful day, it entered the nostrils of a hadrosaur, was absorbed into its bloodstream, and helped power its mighty muscles as it foraged among cycad forests. When that dinosaur exhaled, our molecule returned to the atmosphere, ready for its next adventure. This molecule's journey didn't end with the dinosaurs. It persisted through the mass extinction that wiped them out, perhaps being absorbed by the first mammals that inherited the Earth. It may have been part of the air that filled the lungs of woolly mammoths during the Ice Age, or mixed in the winds that carried early humans across land bridges. It certainly was breathed by countless plants and animals throughout history before finally, today, entering your lungs as you listen to this story. And when you exhale, it will continue its endless journey, perhaps being absorbed by the tree outside your window tomorrow, only to be released again for some future creature to breathe. This is the incredible longevity of Earth. Photosynthesis is the engine that drives this atomic recycling plant, operating continuously for at least 2.5 billion years. Ancient cyanobacteria first developed this miraculous process, learning to harness sunlight to split water molecules and build organic compounds. Today, their descendants, the chloroplasts in every green plant, still perform this alchemy that makes our world possible. The oxygen you're breathing right now was almost certainly produced by some distant plant or phytoplankton, just as the carbon dioxide you exhale will soon nourish another generation of photosynthesizers. This creates an unbroken chain of atomic exchange stretching back to the dawn of complex life, a chain that connects you directly to every plant and creature that has ever lived. Water molecules tell an even more astonishing story of persistence and recycling. The H2O in your body has existed since before the dinosaurs, before the first flowers bloomed, before continents took their current shapes. Some of those water molecules may have been part of the primordial ocean where life first stirred, may have evaporated into clouds that shaded early land plants, may have fallen as rain that filled drinking holes for sauropods. They've been frozen in glaciers during ice ages, boiled in volcanic hot springs, flowed through the veins of giant dragonflies with 2-foot wingspans. Today, they course through your bloodstream, lubricate your joints, fill your cells, temporary way stations in a journey that spans geological epochs. Consider your next sip of water. The hydrogen atoms in that water formed shortly after the Big Bang, making them about 13.8 billion years old. The oxygen atoms joined them about 4.6 billion years ago as Earth coalesced from cosmic dust. Together, they've participated in an endless cycle of evaporation and condensation, of freezing and melting, of being drunk and excreted and transpired by countless organisms across the ages. That same water through Dinosaur KDNY has been transpired by giant prehistoric ferns, has been locked in polar ice caps during glacial periods. The water you'll drink tomorrow may have recently been part of a storm over the Amazon, or melted from a glacier that formed before humans walked the earth, or filtered through limestone caves that didn't exist when T-Rex roamed. This perspective transforms our relationship with the most ordinary acts of breathing and drinking. Each inhalation connects you to every air-breathing creature that has ever lived. Each glass of water contains molecules that have quenched the thirst of history. Your body becomes less a separate entity and more a temporary gathering of ancient atoms, a momentary eddy in the endless flow of Earth's elemental cycles. The calcium in your bones was mined from rocks by plant roots, passed through food chains, perhaps once strengthened the skeleton of a hadrosaur. The iron in your blood was smelted in the cores of dying stars, scattered across the galaxy, and eventually incorporated into Earth's crust before finding its way into your hemoglobin. The carbon atoms forming the backbone of your DNA have an especially adventurous history. Some may have been part of the carbon dioxide exhaled by dinosaurs, absorbed by plants, eaten by herbivores, decomposed into soil, taken up by other plants, and eventually consumed by you. Others might have spent time as limestone on ocean floors before being uplifted into mountains and weathered back into the cycle. Radioactive dating shows that the carbon in your body is genuinely ancient, with some atoms having participated in organic molecules for hundreds of millions of years. This atomic continuity makes all life on Earth fundamentally interconnected. The same nitrogen that helped build proteins in a velociraptor's muscles now helps build yours. The same phosphorus that strengthened an apatosaur's massive bones now strengthens yours. The same water that once pooled in Jurassic mudholes now fills your cells. We are all, humans, dinosaurs, redwoods, algae, temporary assemblies of atoms that have been part of countless lifeforms before us and will be part of countless more after we're gone. As you lie in bed tonight, consider this profound connection. The air moving in and out of your lungs is the same air that has sustained life since the first creatures crawled onto land. The water in your body has flowed through rivers that no longer exist, has been drunk by creatures now fossilized, has been part of storms that shaped continents. You are breathing dinosaur air right now, not metaphorically, but literally. Those oxygen molecules cycling through your bloodstream have been part of this planet's atmosphere since long before humans appeared, and will remain long after we're gone. This realization inspires both awe and humility. We are not separate from nature's cycles, but deeply embedded in them. The atoms comprising our bodies are on loan from Earth's great reservoirs, to be returned when our time is done. This knowledge can transform how we see ourselves, not as isolated individuals, but as brief gatherings of ancient stardust, momentary participants in Earth's eternal breath. So breathe deeply tonight, knowing that with each inhalation, you draw in pieces of planetary history. With each exhalation, you return them to the cycle. You are both inheritor and custodian of atoms that have witnessed the rise and fall of species, the birth and death of mountains, the unspooling of geological time itself. There is poetry in this continuity, comfort in knowing we are all connected through the most fundamental particles of existence. As sleep approaches, imagine those ancient atoms moving through you, oxygen that once fueled prehistoric giants, water that has shaped landscapes over eons, carbon that has formed infinite molecular combinations across the ages. You are their latest temporary home, their most recent collaborator in the endless dance of life. Chapter 2, Dinosaur Air Forensics. Section A, Carbon Timekeepers. The air you breathe is a living archive, carrying within it the breath of giants who walked the earth millions of years before humans appeared. Every exhalation releases carbon dioxide molecules containing atoms that once fueled the mighty hearts of dinosaurs, cycled through prehistoric jungles, and witnessed the cataclysmic asteroid impact that ended the Mesozoic era. This extraordinary continuity exists because carbon atoms are never destroyed, only endlessly recycled through Earth's systems, leaving behind chemical clues that scientists can now read like pages in a history book written in atomic ink. At the heart of this detective story are carbon isotopes, subtle variations of carbon atoms that serve as nature's barcodes. Most carbon exists as carbon-12, with 6 protons and 6 neutrons, but about 1% takes the slightly heavier form of carbon-13 with an extra neutron. Plants during photosynthesis strongly prefer the lighter carbon-12, creating a distinctive isotopic signature in all organic matter. When we analyze the carbon in 100-million-year-old fossilized leaves and compare it to modern plants, we find the same isotopic ratios, proving the same carbon atoms have been continuously cycling through living systems. The mathematics of this molecular recycling reveals astonishing connections. Earth's active carbon cycle contains approximately 43,500 billion metric tons of carbon moving through the biosphere, atmosphere, and oceans. During the Cretaceous period's peak biological productivity, dinosaurs and their contemporary plants comprised about 2,200 billion tons of living biomass. This means roughly 5% of all carbon atoms currently participating in Earth's surface processes must have originated from organisms alive during the age of dinosaurs. Statistically, this translates to 1 out of every 20 carbon dioxide molecules you exhale containing carbon that was once part of a dinosaur's lunch. Perhaps a mouthful of ginkgo leaves swallowed by a hadrosaur, or the flesh of smaller dinosaurs consumed by predators. These connections become visible in remarkable ways. In Montana's Hell Creek Formation, scientists have analyzed carbon isotopes in fossilized Tyrannosaurus rex teeth, revealing seasonal changes in their diet that correspond to plant growth cycles. The same isotopic patterns appear in modern ecosystems, showing the unbroken continuity of carbon's journey. When you eat vegetables today, you're consuming carbon atoms that followed identical biochemical pathways when they were part of plants eaten by dinosaurs, the same atoms being incorporated into tissues through the same basic metabolic processes. Ice cores from Antarctica provide perhaps the most compelling evidence. Trapped within these ancient ice layers are microscopic air bubbles, perfectly preserved samples of Earth's atmosphere from times when dinosaurs roamed. Analyzing these bubbles shows carbon isotope signatures identical to those in modern air, proving the continuity of the carbon cycle. The carbon dioxide you just exhaled contains atoms with the same isotopic composition as those exhaled by a Triceratops 68 million years ago, a literal breath across time. Your own body serves as a museum of these recycled atoms. The carbon in your DNA shares chemical bonds with genetic material from countless extinct species. The lipids in your cell membranes follow molecular architectures first developed by prehistoric organisms. Even the cholesterol in your bloodstream traces its origins to early eukaryotes that lived before multicellular life existed. This atomic continuity means parts of your physical being, quite literally, once belonged to dinosaurs, not metaphorically but through demonstrable biochemical pathways. The implications extend beyond mere curiosity. This carbon cycle represents Earth's greatest recycling program, operating continuously for billions of years without mechanical parts or human. A carbon atom in your fingertip might have been part of a Jurassic fern that shaded nesting sauropods, the chitinous shell of a Cretaceous beetle, the cartilage of a pterosaur's wing, the ink of an ancient squid-like creature, the hide of a mammal that scurried beneath dinosaur feet. All these transformations occurred through nature's patient chemistry, no atoms created or destroyed, only rearranged through respiration, decomposition, sedimentation, and uplift. The same carbon atoms have formed infinite molecular combinations across geologic time, with each configuration representing just a temporary stopping point in an endless journey. As you breathe tonight, consider this profound connection. The rise and fall of your chest continues a rhythm established when the first lungs evolved. The oxygen entering your bloodstream follows pathways perfected over hundreds of millions of years. The carbon dioxide you exhale will nourish plants that may feed future generations in an unbroken chain stretching backward and forward through time. You are both inheritor and custodian of atoms that have witnessed the entire pageant of life on Earth, atoms that will continue their journey long after our species is gone. This is the true wonder of carbon timekeeping, Not just that we breathe dinosaur air, but that we are temporary gatherings of atoms that have participated in life's grand story since its beginning. Your next breath will draw in molecules that have known other lungs, other leaves, other seas. Your next exhalation will return them to the cycle, little changed but carrying new memories of their time as part of you. In this way, we are all, humans, dinosaurs, redwoods, algae, connected through the most fundamental particles of existence, participants in Earth's eternal respiration. Section B, the Cretaceous Atmosphere. The air that filled dinosaur lungs was both alien and familiar, a thick, warm blanket of gases that would feel strangely heavy to modern humans. As you inhale deeply, consider how different Earth's atmosphere was when T-Rex hunted its prey. The nitrogen molecules you're breathing now have survived unchanged through that entire history, silent witnesses to the rise and fall of empires of flesh. During the Cretaceous period, Earth's air contained 30 to 35% more oxygen than today's atmosphere. This supercharged gas mixture allowed for astonishing biological experiments, dragonflies with 2-foot wingspans that patrolled swampy deltas, birds capable of flying at altitudes that would leave modern eagles gasping, and dinosaurs whose bone structure suggests metabolisms approaching warm-bloodedness. The enhanced oxygen levels made even ordinary activities extraordinary. A sprinting raptor could take in nearly 50% more oxygen per breath than an equally sized modern animal, fueling bursts of speed we can scarcely imagine. Carbon dioxide told an even more dramatic story. At 1,000 to 1,400 parts per million, compared to today's 420 ppm, Cretaceous CO2 created a greenhouse effect so intense that palm trees grew in Alaska and coral reefs thrived near the poles. This dense CO2 blanket diffused sunlight into perpetual golden hour, a world washed in amber tones where shadows stayed soft even at midday. Plants grew with frantic urgency under these conditions, ferns could reach full size in weeks rather than months, creating jungle densities that make the Amazon look sparse by comparison. Yet through all these atmospheric changes, the nitrogen molecules remained remarkably constant. Nitrogen's triple-bonded N2 structure makes it incredibly stable. The average nitrogen molecule survives about 10,000 years in the atmosphere before being broken apart by lightning or soil bacteria. This means the nitrogen entering your lungs right now has cycled through Earth's atmosphere approximately 300,000 times since the Cretaceous ended. Some of these very molecules were present when the first flowers evolved their petals. Tyrannosaurs battled Triceratops. The Chicxulub asteroid painted the sky with molten rock. Woolly mammoths trudged across frozen steppes. Volcanic activity during the Cretaceous added further complexity to the air. The Deccan Traps eruptions, lasting 30,000 years, pumped enough sulfur dioxide into the atmosphere to create acid rain on continental scales, while the simultaneous CO2 emissions maintained sweltering greenhouse conditions. These volcanic gases interacted with sunlight to produce atmospheric effects beyond modern experience, sunsets that burned with neon oranges and electric purples, created by high-altitude sulfate aerosols refracting light through the thick, humid air. Your body still carries physiological echoes of these ancient atmospheres. The hiccup reflex may originate from when our amphibian ancestors switched between oxygen-rich air and oxygen-poor water. The burning sensation when you hold your breath too long reflects oxygen levels our ancestors never experienced. Even the way you yawn follows neural pathways developed when different atmospheric conditions required more efficient gas exchange. These are ghost imprints left by atmospheres past, written into our very biology. Modern technology lets us simulate these ancient conditions. NASA studies how dinosaurs perceived color under different atmospheric light filtering. Paleobotanists grow Cretaceous plant species in climate-controlled chambers with period-accurate air mixtures. These experiments reveal surprising adaptations. Many dinosaur-era plants grew faster under high CO2 but required sophisticated chemical defenses against increased UV radiation penetrating the thinner ozone layer of the time. As you prepare for sleep tonight, consider the nitrogen now filling your lungs, Earth's most faithful timekeeper. While oxygen comes and goes, while carbon cycles through life, nitrogen remains the constant background against which Earth's drama unfolds. The next deep breath you take will draw in molecules that witnessed the rise and fall of dinosaurs. That persisted through ice ages and heat waves, that will likely still be here when human civilization is just another layer in the geologic record. This is the true gift of atmospheric science, not just understanding what dinosaurs breathed, but recognizing our shared atomic heritage with all life. Whether T-Rex or human, whether cycad or oak tree, we all participate in the same eternal cycles of gas exchange that have sustained life for hundreds of millions of years. Your breath tonight continues that unbroken chain, a living link between prehistoric past and unimaginable future. The Cretaceous atmosphere may be gone, but its molecules remain, in every breath, in every cell, in the very air that rustles your curtains tonight. As sleep comes, imagine those ancient nitrogen molecules surrounding you like invisible guardians of deep time, whispering stories of worlds long vanished as they pass once more through your lungs, unchanged but carrying new memories of their brief time as part of you. Chapter 3, Your Body's Ancient Atoms. Section A, Stardust to Cells. Place your hand over your heart and feel the steady rhythm beneath your palm. That pulse you detect is powered by atoms older than the Earth itself, particles that have journeyed across galaxies and through millennia to become part of you. The iron coursing through your bloodstream right now was forged in the heart of a dying star more than 5 billion years ago, the same stellar furnace that created the gold in your jewelry and the calcium in your bones. These atoms have known other hearts before yours, perhaps pumping through the massive four-chambered heart of a Tyrannosaurus rex, or circulating in the veins of the first mammals that scurried beneath dinosaur feet. The hydrogen atoms in your body tell the most ancient story of all. Every water molecule in your cells contains hydrogen atoms that formed just 380,000 years after the Big Bang, making them approximately 13.8 billion years old. When you sip water today, you're drinking the same hydrogen that once filled primordial oceans, that evaporated into the atmosphere of a young Earth, that was carried in the blood of every creature in your evolutionary lineage. These hydrogen atoms have participated in an unbroken chain of life stretching back to the first self-replicating molecules in hydrothermal vents. They were there when photosynthesis first transformed Earth's atmosphere, when plants colonized land, when dinosaurs evolved feathers. Your calcium tells another cosmic tale. Nearly all the calcium in your bones was created in supernova explosions, violent stellar deaths that scattered these atoms across interstellar space. The same calcium that strengthens your skeleton once hardened the shells of ancient sea creatures, built the massive frames of sauropod dinosaurs, and fortified the antlers of Ice Age megafauna. When you drink milk, you're absorbing calcium atoms that may have cycled through hundreds of organisms across geologic time, from Devonian fish to Jurassic crocodiles to Pleistocene cave bears, before becoming part of you. The phosphorus in your DNA has an equally dramatic history. This element, essential for energy transfer in all living cells, was likely delivered to Earth by meteorites during the late heavy bombardment period 4 billion years ago. The phosphate groups linking your DNA's double helix contain atoms that have been part of genetic material since life first began storing information in molecules. These phosphorus atoms have witnessed every evolutionary innovation, the development of multicellularity, the conquest of land, the dawn of consciousness, while maintaining their fundamental role in preserving and transmitting biological information. Your body's sodium and chlorine, the components of table salt, carry memories of ancient seas. The salt in your tears, sweat, and blood plasma has the same basic composition as ocean water from 500 million years ago. When you cry, the salt on your cheeks contain chloride. That may have dissolved from volcanic eruptions during the age of dinosaurs, sodium atoms weathered from mountains that no longer exist. These salts have maintained the precise electrolyte balance necessary for nerve impulses across countless generations of organisms, from the first fish that developed complex nervous systems to the dinosaurs that ruled Mesozoic ecosystems to the humans who eventually wondered about their atomic origins. The zinc in your enzymes, the magnesium in your muscles, the copper in your blood, all these metals were created in stellar explosions and asteroid collisions before Earth formed. They've cycled through countless organisms, each temporary host adding new chapters to their cosmic story. The copper atoms facilitating oxygen transport in your blood may once have helped pigment the feathers of a Confuciusornis, an early Cretaceous bird. The zinc atoms enabling your sense of taste might have been part of enzymes in a hadrosaur's digestive system. Even the carbon forming the backbone of your organic molecules carries ancient histories. Radiocarbon dating shows that the carbon atoms in your body have participated in living systems for hundreds of millions of years. Some may have been part of the first forests that changed Earth's atmosphere, others might have cycled through dozens of dinosaur generations before finding their way into your cells. The same carbon atoms have formed infinite molecular combinations, as plant cellulose, as chitin in insect exoskeletons, as keratin in dinosaur feathers, and now as the proteins and fats that make up your body. As you lie in bed tonight, consider this profound continuity. The atoms comprising your body are not new creations, they're ancient travelers on an endless journey through time and space. Your life represents just one brief stop on their cosmic itinerary, a momentary gathering of stellar material into conscious form. The iron in your blood will someday nourish new life, the carbon in your cells. The hydrogen in your body will continue its journey through water and air. This realization transforms our understanding of self. You are not separate from the universe, but a temporary configuration of its oldest materials, a gathering of stardust that has learned to contemplate its own origins. The calcium in your bones, the iron in your blood, the phosphorus in your DNA, these atoms have seen the birth and death of stars, have witnessed the rise and fall of species, and now, for this brief moment, have come together to form you. So breathe deeply tonight, knowing that with each inhalation, you draw in pieces of cosmic history. With each heartbeat, you circulate atoms that have known other hearts in other times. You are both ancient and brand new, a collection of primordial materials experiencing the modern world through human eyes. As sleep comes, imagine those atoms whispering their stories to your cells, tales of supernovae and dinosaurs, of ice ages and civilizations, all contained within the quiet rhythm of your resting body. Section B, Shared Atoms. Take a deep breath and consider this. The air now filling your lungs almost certainly contains at least one molecule that was exhaled by Julius Caesar as he lay dying on the Senate floor, another that passed through the lungs of Cleopatra during her famous meetings with Roman leaders, and several more that once sustained woolly mammoths roaming the frozen tundra. This isn't poetic speculation but statistical certainty, a mathematical inevitability resulting from the mind-boggling numbers of molecules in Earth's atmosphere and their relentless circulation over centuries. The nitrogen molecule you just inhaled has likely been breathed by every historical figure you can name, from Shakespeare to Genghis Khan, from Queen Elizabeth I to the last Neanderthal, before finding its way to you. The mathematics behind these atomic reunions is both simple and staggering. Earth's atmosphere contains approximately 10 to the power of 44 molecules of air. A number so vast it exceeds all grains of sand on every beach combined. An average human breath contains about 10 to the power of 22 molecules. Given that all humans who ever lived have collectively exhaled roughly 10 to the power of 34 molecules, probability dictates that each of your inhalations must contain at least one molecule from the last breath of any given historical figure. That means with every breath, you're statistically inhaling fragments of air that once sustained Leonardo da Vinci as he painted the Mona Lisa, that cooled Muhammad Ali's brow during championship bouts, that filled the sails of Viking ships crossing the North Atlantic. This molecular sharing extends far beyond human history. The water molecules in your body have participated in an endless cycle of evaporation and condensation that has been running continuously since Earth's oceans formed. Some of the H2O molecules currently hydrating your cells may have once slaked the thirst of a thirsty Tyrannosaurus rex panting after a hunt, or been part of the morning dew on ferns nibbled by giant sauropods. Others might have frozen into glaciers during ice ages, evaporated from primordial seas before the first fish evolved, or fallen as rain on the backs of the earliest amphibians crawling onto land. The water you drink today is quite literally the same water that has nurtured all life on Earth, a cosmic inheritance flowing through your veins. Your body's carbon atoms weave an even more intricate web of connection. The average human body contains about 16 kilograms of carbon, atoms that have cycled through countless life forms before becoming part of you. Statistical models suggest that your body likely contains at least one carbon atom that was once part of any given historical figure you can name. The calcium in your bones shares atomic identity with the skeletons of dinosaurs, early hominids, and every ancestor in your direct lineage. The iron in your blood has known other circulatory systems, perhaps oxygenating the muscles. This atomic continuity reveals a profound kinship that stretches across time, species, and galaxies. The sodium-potassium pumps firing in your neurons today operate by the same fundamental principles that once powered the nervous systems of ancient creatures long extinct. The hemoglobin flowing through your bloodstream follows molecular blueprints first drafted when the earliest vertebrates began transporting oxygen. Even the double helix of your DNA carries whispers from lifeforms that roamed the Earth when the continents were still joined as Pangea. At the atomic level, the divisions we draw, between species, between the living and the dead, between now and then, begin to fade into something beautifully shared. Of all the elements cycling through your body, nitrogen perhaps tells the most astonishing tale. Nitrogen molecules, N2, are remarkably stable, often persisting in the atmosphere for nearly 10,000 years before being broken apart by lightning or soil bacteria. This means the nitrogen you're breathing right now may have remained unchanged since before the Egyptian pyramids rose from the sand. It has silently floated through the ages, untouched and eternal, present when the first cities emerged in Mesopotamia, when Buddha found enlightenment beneath the Bodhi tree, when Mongol horsemen galloped across Eurasia, and when astronauts looked back at Earth from the moon. Your body, in truth, is a museum of cosmic relics, each atom a silent witness to eons of history. The gold in your ring was born in the heart of colliding neutron stars, long before our solar system existed. The uranium drifting through you in infinitesimal amounts is the fading glow of ancient supernovae. Even the rare earth metals in your smartphone, like neodymium and europium, were forged in kilonova explosions so powerful, they briefly warped the very fabric of spacetime. You are, quite literally, made of the universe's oldest memories. This perspective transforms our understanding of personal identity. You are not an isolated being but a temporary gathering of ancient materials, atoms that have known other lives, other forms, other stories before becoming part of yours. When you touch someone's hand, your atoms are mingling with theirs in patterns that may have repeated countless times across geologic eras. The oxygen you exhale today may tomorrow nourish a redwood tree whose ancestors shaded dinosaurs. The carbon in your cells will eventually cycle back into the biosphere to become part of future lifeforms we can't yet imagine. As you prepare for sleep tonight, consider this profound continuity. The rise and fall of your chest continues a rhythm established when the first lungs evolved. The atoms flowing through you have participated in every chapter of Earth's story, from violent beginnings to the emergence of consciousness. Your body is less a singular entity than a crossroads where cosmic histories intersect, where stardust from different galaxies, materials from different epochs, all come together to form the unique constellation that is you. This realization brings both humility and connection. We are simultaneously insignificant in the cosmic scale of time, yet fundamentally linked to all existence through our shared atoms. The same particles have been part of emperors and ants, of redwoods and reptiles, of oceans and atmospheres. Your life represents just one particularly interesting arrangement of these eternal materials, a configuration that can ponder its own atomic ancestry. So breathe deeply in the darkness tonight, knowing that with each inhalation, you draw the universe into yourself. With each exhalation, you return those borrowed atoms to the great cycle. The boundaries we perceive between self and world are illusions. At the atomic level, we are all continuous with everything that ever was and everything that ever will be. Your body is the universe's way of experiencing itself. A collection of ancient atoms temporarily arranged to wonder about their own origins before returning to the cosmic flow. Chapter 4, Nighttime Time Travel. Section A, Dream Science. As you drift into sleep tonight, your body begins an extraordinary alchemical process, transforming ancient atmospheric molecules into the very fabric of your dreams. The oxygen you inhale in those final waking moments carries atoms that have participated in biological rhythms for hundreds of millions of years, and now your sleeping metabolism will put them to work in ways that science is only beginning to understand. This nightly respiration ritual connects you directly to Earth's deepest past. While you slumber, your cells engage in molecular time travel, processing atmospheric relics through biochemical pathways older than the dinosaurs themselves. The mechanics of this ancient oxygen processing reveal evolutionary marvels preserved in your sleeping body. During deep sleep stages, your cellular metabolism shifts to prioritize repair and memory consolidation, processes that utilize oxygen with remarkable efficiency. The mitochondria in your cells, those tiny powerhouses descended from free-living bacteria billions of years ago, become particularly active during REM sleep. As they generate energy by combining oxygen with nutrients, they're essentially burning the same atmospheric molecules that once fueled prehistoric organisms. The iron atoms in your hemoglobin, forged in supernovae before Earth formed, bind these oxygen molecules with the same precise geometry that evolved when the first vertebrates developed blood-based respiration. While you dream, your body maintains this unbroken chain of gas exchange that has sustained complex life since the Carboniferous period. Sleep scientists have discovered fascinating connections between atmospheric chemistry and dream content. The slight increase in carbon dioxide level that occurs during normal sleep respiration appears to stimulate more dream. Perhaps an evolutionary holdover from when our ancestors slept in dense, CO2-rich environments like caves or enclosed nests. The oxygen isotopes you inhale at night, some containing slightly heavier or lighter variants of oxygen atoms, may influence neural activity in ways we're only beginning to map. Your sleeping brain processes these ancient molecules through neural networks that themselves contain atoms recycled from countless previous lifeforms, creating a literal meeting of minds across geologic time. The nitrogen molecules surrounding you as you sleep tell an even more astonishing story of persistence. Unlike oxygen, which gets continually broken down and recombined through metabolic processes, nitrogen molecules, N2, can remain intact in the atmosphere for thousands of years. The nitrogen now filling your bedroom has likely witnessed every major event in human history unchanged, from the construction of the pyramids to the invention of electric light, before participating in your nightly respiration. As you breathe in and out during sleep, these nitrogen molecules remain chemically aloof but physically present, like silent observers to your personal nightly metamorphosis. Your body's handling of these ancient atmospheric components during sleep reveals profound evolutionary continuity. The circadian rhythms governing your sleep-wake cycle evolved in response to Earth's rotation under primordial skies. The melatonin that makes you drowsy tonight follows molecular templates established when the first mammals evolved nocturnal habits to avoid dinosaur predators. Even your sleeping posture, whether curled on your side or stretched on your back, echoes positions adopted by our ancestors for thermoregulation and predator vigilance. Every aspect of your nightly journey exists within biological parameters shaped by eons of atmospheric interaction. The water vapor in your breath as you sleep carries its own cosmic history. Each exhale releases hydrogen atoms that date back to the Big Bang and oxygen atoms forged in ancient stars. These water molecules have cycled through Earth's systems for billions of years, evaporating from Devonian seas, condensing on Jurassic leaves, freezing in Ice Age glaciers, before becoming part of you. During sleep, your body's water conservation systems become particularly efficient, minimizing loss while allowing just enough evaporation to maintain optimal respiratory function. This delicate balance follows physiological principles refined over hundreds of millions of years of terrestrial life. As you transition through sleep stages tonight, your cells will perform their most profound atomic alchemy. In slow-wave sleep, your body prioritizes physical repair, using ancient oxygen atoms to help mend tissues, synthesize proteins, and strengthen your immune system. During REM sleep, your brain becomes hyperactive while your body enters paralysis, a state where those same oxygen molecules fuel the creation of dreams while preventing you from acting them out. This intricate dance between activation and inhibition follows neural pathways established when our ancestors first developed complex sleep patterns. The calcium ions flowing through your neurons as you dream have known other nervous systems, perhaps facilitating the first synaptic connections in early fish, or modulating the sleep-wake cycles of primitive mammals. The potassium and sodium generating your brain's electrical activity tonight follow concentration gradients perfected over eons of evolutionary experimentation. Even the neurotransmitters carrying signals between your neurons, dopamine, serotonin, acetylcholine, are molecular cousins to chemicals that regulated mood and alertness in creatures extinct for millions of years. Tonight, as your breathing slows and sleep pulls you under, remember this: the atoms now circulating through your dreaming brain have participated in countless biological nights before yours. The oxygen nourishing your neurons once. Dinosaur brains processing primitive dreams, early humans envisioning the first stories, every ancestor in your lineage who ever closed their eyes in sleep. Your nightly journey connects you to them all through unbroken chains of respiration and metabolism, an atomic continuity that makes sleep the most ancient time machine we possess. As dreams carry you away, imagine those ancient oxygen atoms whispering their stories to your cells, tales of primordial atmospheres, of extinct ecosystems, of survival strategies honed over geologic time. Your sleeping body knows these stories at a cellular level, following rhythms written into your DNA by generations of ancestors who successfully navigated their own nights. The same atoms that now fuel your dreams will someday nourish future life, completing the cycle that began long before your birth and will continue long after. Sleep well, time traveler. Tonight's journey through the eons begins with your next deep breath. Section B, Guided Visualization. As the veil between wakefulness and sleep grows thin tonight, let us embark on a journey unlike any other, a voyage through time itself, propelled by the simple rhythm of your breathing. Picture your breath as the most ancient time machine ever conceived, each inhalation drawing in echoes of Jurassic twilight, each exhalation releasing them transformed into the cosmic future. The air flowing through your nostrils right now carries molecules that have witnessed the rise and fall of mountain ranges, the birth and death of stars, the unspooling of Earth's grandest stories, and tonight, they will whisper these secrets to your dreaming mind. Begin by settling deeper into your pillow, feeling the weight of your body gradually surrender to gravity's gentle pull. With your next slow, deliberate inhalation, imagine drawing in air from a steamy Cretaceous evening, thick with the scent of giant ferns and damp earth, carrying extra oxygen that makes your lungs feel supercharged. Picture this prehistoric air swirling through your bronchial branches like warm honey, each alveolus accepting these ancient molecules as honored guests. As the oxygen crosses into your bloodstream, visualize it awakening cellular memories older than consciousness itself, your hemoglobin molecules recognizing these atmospheric visitors from their long evolutionary acquaintance. Now, as you exhale, envision your breath joining Earth's eternal atmospheric river, your carbon dioxide molecules floating upward to nourish the same types of cycads and conifers that shaded dinosaurs. With each subsequent breath, travel further back through time, inhale the crisp, metallic air of the early Jurassic when giant sauropods first evolved their enormous necks, exhale into landscapes where the first mammals cower in moonlit underbrush. Draw in the carbon-scarce atmosphere of the late Permian, rich with unfamiliar floral scents from plants now extinct, release your breath to mingle with the winds that cooled the brows of saber-toothed gorgonopsids. Gradually shift your temporal journey to more recent epochs. Inhale the icy, crystalline air of Pleistocene glaciers, so cold it burns your lungs yet carries the thrilling purity of unspoiled atmosphere. Exhale into valleys where woolly mammoths trumpet their lonely songs across frozen steppes. Breathe in the smoky campfire air of early human settlements, thick with the promise of civilization. Release your breath to join the winds that carried Phoenician ships across uncharted seas. Each intentional breath becomes a bridge between eras, your respiratory system the constant through which Earth's changing atmospheres find temporary reunion. Now turn your attention to the water vapor in your breath, those hydrogen atoms nearly as old as time itself. Imagine them carrying memories of primordial seas where life first stirred, of torrential carboniferous rains that nourished giant insects, of morning dew on dinosaur skin. With each exhalation, picture these water molecules beginning new adventures, perhaps to form part of a thunderstorm over the Amazon, or to freeze into an Antarctic glacier that won't melt for 10,000 years, or to be drunk by some future creature not yet evolved. As sleep draws nearer, expand your visualization to include the nitrogen molecules passing harmlessly through your system, the silent witnesses to Earth's entire history. These indestructible diatomic pairs have floated unchanged through asteroid impacts and mass extinctions, through the birth of agriculture and the rise of cities. Picture them now as wise elders observing your brief but precious life, their molecular bonds remaining steadfast as human civilizations rise and fall around them. Finally, contemplate the most profound time travel of all, the iron in your blood, forged in supernovae explosions before our solar system formed. Visualize these ancient atoms, having waited billions of years in interstellar space, now coursing through your veins, temporarily part of your biological story before continuing their cosmic journey. The calcium in your bones, the phosphorus in your DNA, the sodium in your nerves, all carry similarly epic histories of stellar nucleosynthesis and planetary recycling. As you hover on the edge of sleep, release all conscious effort and simply become aware of breathing itself, this automatic miracle connecting you to all breath that ever was and ever will be. Notice how your body knows exactly how to process these ancient molecules without your conscious direction, following biochemical pathways refined over eons. Your diaphragm moves with the same rhythm that sustained your ancestors, your heart pumps with the same purpose that animated prehistoric creatures, your cells metabolize with the same ancient wisdom encoded in life's earliest forms. Tonight, as dreams claim you, remember, you are not breathing air so much as inhaling time itself. The boundaries between past, present and future dissolve at. What was dinosaur breath becomes your breath becomes some future organism's breath in an endless cycle of renewal. Your sleeping body becomes the crucible where Earth's deep past and unimaginable future meet briefly in the present moment, where stardust becomes consciousness becomes dream becomes stardust once more. Let this knowledge cradle you into deeper sleep. You are both time traveler and time capsule, both ancient and newborn, both individual and continuous with all existence. The universe breathes through you tonight, as it has through countless creatures before and will through countless more to come. Surrender now to this cosmic rhythm, and may your dreams carry you where only atoms dare to go. Now we go towards soothing conclusion. As the final whispers of consciousness fade and sleep begins to claim you, let us gather all these threads of cosmic connection into a comforting tapestry of understanding. The journey we've taken together through these chapters is not merely intellectual, it is a profound reimagining of your place in the grand continuum of existence. With each slowing breath, as your eyelids grow heavy and your muscles relax, remember this fundamental truth: you are not separate from the universe, but a living, breathing expression of its most ancient processes. The rise and fall of your chest continues a rhythm older than the first lungs that ever drew breath on this planet, a sacred cadence that links you to every creature that has ever lived and died beneath Earth's ever-changing skies. The air moving through your nostrils at this very moment carries molecules that have known other nights, other dreamers, other forms of consciousness now lost to deep time. The oxygen entering your bloodstream will soon nourish cells that themselves are composed of recycled stardust, atoms that have participated in life's great adventure since its earliest beginnings. As you exhale, you return these borrowed materials to the eternal cycle, little changed but carrying new memories of their brief time as part of you. This is the great reciprocity of existence: we borrow stardust, shape it momentarily into our singular being, then release it back to the universe to become part of new stories. Your lungs are not just organs of respiration but portals through which cosmic history flows, the last stop on these atoms' current journey, and the launching point for their next adventure. Consider the miraculous continuity embodied in something as simple as your nighttime breathing. The iron atoms in your hemoglobin, forged in some long-dead star's final moments, now bind oxygen with the same elegant efficiency they've shown for hundreds of millions of years. The water molecules hydrating your cells have quenched the thirst of countless organisms before you. Even the nitrogen molecules that pass unchanged through your system have witnessed the entire span of human civilization without altering their fundamental nature. You are, in the most literal sense, a gathering of the universe's memories, a temporary constellation of ancient atoms that has learned to contemplate its own origins. As sleep's tide pulls you deeper, release any lingering sense of separation from the world around you. The boundaries we perceive between self and environment are illusions. At the atomic level, there is only continuous exchange. The carbon dioxide you exhale tonight may tomorrow become part of a maple leaf structure. The water vapor from your breath could join clouds that will rain on future forests. The salts in your sweat will return to the earth to nourish new growth. You are not in the universe so much as you are of it, an intrinsic participant in processes that began before life itself and will continue long after human consciousness has transformed into forms we cannot imagine. Let this knowledge cradle you into deeper relaxation. The same forces that shaped galaxies and spun solar systems from dust now sustain your sleeping body. The same laws of chemistry that governed dinosaur metabolism now regulate your cellular respiration. The same gravitational pull that keeps planets in orbit now holds you gently to your mattress. You are safe because you are not separate, you are the universe experiencing itself through human form, dreaming human dreams, asking human questions about origins and meaning. Tonight, as dreams begin their mysterious work, you might find yourself flying with pterosaurs over steaming Jurassic lagoons, or swimming through primordial seas as the first life stirs in tidal pools. Perhaps you'll wander through alien landscapes that somehow feel like home, because the atoms comprising your dreaming brain have known so many different versions of Earth. These visions are not mere fantasy but cellular memories surfacing from the deep time encoded in your very molecules. Your body remembers worlds it never consciously knew because its components have known them intimately. As you hover between waking and sleeping, consider one final revelation: the present moment, this exact point in time where past and future meet, is where all of cosmic history has been leading. Every supernova explosion, every tectonic shift, every evolutionary adaptation has conspired to create this instant where the universe becomes aware of itself through you. The oxygen atoms now fueling your thoughts represent the culmination of billions of years of stellar alchemy. The neural networks flickering with drowsy consciousness embody eons of evolutionary refinement. Even your ability to comprehend these ideas stems from cognitive capacities honed through generations of ancestors who successfully navigated their own nights. Now, as true sleep finally claims you, release all effort and simply be, a momentary gathering of stardust granted the extraordinary privilege of self-awareness. Your slowing breaths mark the rhythm of the cosmos itself, expansion and contraction, inhalation and exhalation, the endless dance of energy and matter. That began with the first instant of time. The worries of tomorrow, the regrets of yesterday, all dissolve into the timeless present where atoms remember their origins and dreams weave new possibilities. May you rest tonight cradled by this profound connection, knowing you are never alone but always part of the universe's great story. And when you wake tomorrow to draw that first conscious breath, may you remember, if only for a fleeting moment, that the air filling your lungs contains whispers from the dawn of time itself, and that your life represents the universe's way of knowing itself anew. Sleep deeply, time traveler. The journey continues with every beat of your heart, every rise and fall of your chest, every dream that carries you beyond the boundaries of space and time. The atoms that comprise you have waited 13.8 billion years for this night's rest, may it be worthy of their patience. Good night.